Alright guys, today we're going to be going over this lesson. Remember, I'm not going to be here, but I fully expect you to watch this video if you don't understand it. Now I'm going to upload this video onto YouTube, so if you still don't get it, I want you to go back and watch this a couple of times. Pause it whenever you need to, but you need to make sure you understand this before I get back. Alright, so we actually have done something like this in the past. If you remember, to graph this without a calculator, remember we talked about this in the past, we'd say that the points that we need would be 0, 0, 1, 1, 2, 4, 3, 9. The other points that you also need are negative 1, 1, negative 2, 4, and negative 3, 9. Now remember that I have the y coordinate. How I got that was by squaring the x coordinates. So if I square the x, I get the y. Okay, so if I remember those points, and hopefully you remember this from the beginning of the year, this is how you graph it. Remember that we're going to start off right here, right in the middle, 0, 0. Then we have 1, 1. Then we have 2 to the right 2 up 4. And we also have negative 1 up 1, so to the left 1 up 1. Negative 2, so x is negative 2, and then we're going to go up 4. Alright, now I could also graph 3 and 9 and negative 3 and 9, but for what we're going to need today, that's really all we need. We just need the coordinates of between negative 2 and positive 2. Okay, so remember that this graphs a parabola. Alright, so we're basically doing the same thing we've done in the past. Now, right here is asking me for the vertex. Now, the vertex is actually that point right there. So this right here is actually called a vertex. Okay, so when it's asking us for the vertex here, if you remember from back when we did this, we would say that this is to the right 5 and down 8. Now remember that this is a little strange because it says negative 5. But we say that x is a liar, so every time we see this, this is going to be the opposite. So this is going to be to the right 5 and down 8. Therefore, my vertex is actually going to be 5 and negative 8. Right, so again, that came from those two numbers right there. The opposite of that one and exactly the same thing as that one. Okay, so how we did this in the past, if you remember, was that we would come here and then we'd graph our vertex. So we go to the right 5, 1, 2, 3, 4, 5, and down 8. So that was our first point. Now before we go on with the next points, if you remember, we're going to use exactly the same points that we have at the top. Now the whole point of this was to graph this without a calculator. Alright, so those are the points that we need. Now if you remember though, however, before we start graphing any points, is that this number 2 is actually going to stretch out that parabola vertically. So to do that easily, that's basically the same thing as multiplying all of the y coordinates by 2. So now this y coordinate is going to become 8, 2, 0, 2, and 8. Okay, so from this point right here, from the vertex, we're going to go right 1 and up 2. And then we're going to go to the right 2, or again, I'm right here, 2, and then we're going to go up 8. Alright, so when I go up 8, I'm actually going to be touching the x-axis. Now this is symmetrical, meaning if I have those points right here, those other points are going to be the same distance from this line right here, which is called the axis of symmetry, but we'll cover that later. So that is all I need. Okay? If I'm going too fast, remember, you can always ask the person who is here to pause it, or if you're watching this on your own, just pause it and make sure that you can keep up. Alright, on number 3. Example 3. Now on this one, we haven't understood 0 here. Okay? So our vertex is actually going to be the opposite of this number, which is going to be negative 5. And it's going to be exactly this number for the y coordinate. So we have negative 5, 0. So at that point, we're going to go to the left, 1, 2, 3, 4, 5. And actually, we're not going to go up or down, so that's our vertex right there. Now, this is not being stretched. However, that negative right there, this negative, is going to make this reflect over the x-axis. So therefore, if this were our normal points, 1, 1, 2, 4, negative 1, positive 1, negative 2, positive 4. Now again, remember these are the points for y equals x squared. Right? These are the points for my parent function. Now, what I'm going to do now to make this easier for myself is that basically to reflect over the x-axis, that's the same thing as me multiplying all these by a negative 1. Okay? So instead of 4, I'm going to have negative 4. Instead of 1, I'm going to have negative 1. So basically all that happens is that the signs on the y coordinates are switched. Alright, so again, those points will be to the right 1, but instead of going up 1, I'm going to go down 1. Again, that's the first point that I have right here. 1, 1, or 1, negative 1 now. Now the second point would be 2, 4, or to the right 2, and down 4, because it's being reflected. So that's that point right there. And finally the other points, because we have this is symmetrical. It's symmetrical through the vertex. So these are exactly the same points, same distance from that line. Alright, so that's what that one looks like. Alright, so let's take a look at the back. So again, if you are falling behind in the notes, just pause it, and then we'll go on to the next one. Okay, so let's go on to the back. Now in this one right here, this may look a little different to you, but if we rewrite it in a different way, this is the same thing as writing negative x plus 0 squared plus 3. Okay, so what that means is, if you look at this, is that our vertex is going to be located at 0, 3. Okay, so our vertex is going to be located at 0, 3, which is right here. Now, this is also being reflected. It's not being stretched because there's no number in front of this x squared, but it is being reflected. So what's going to happen is the same thing that happened in the last one, except for my starting point where my vertex is going to be different. So from this point, I'm going to go to the right 1, down 1, to the right 2, down 4, and it's symmetrical around the vertex, or it's symmetrical around the x equals 0. And that's what that one looks like. Okay? Now, you should remember this from the past. So, if you got questions, make sure you go and rewatch this video. Now, before you tune this out, I'm going to do this last two examples. And after this, I'm going to do one from the homework. Okay? So make sure you stay tuned and don't tune out yet. Again, pause it if you're falling behind. So on this one right here, this is called the root form. Alright, now the root form is actually very easy. What that means is that this number and this number are the roots of the quadratic function. Another way to say roots is the same thing as the x-intercepts. Alright, so let's take a look. But the only thing that is strange is that they're going to be the opposite. So instead of negative 3, I'm going to go to positive 3. 1, 2, 3. And on this one, instead of 1, I am going to go to negative 1. So again, on the root form, an equation that looks like this, we're going to take the opposite of those two numbers. Okay, now, it's asking me for what the roots are. Well, the roots are going to be, like we just said, is going to be 3 and negative 1, or the opposite of those two. Now, to find the vertex, well, we don't know what the vertex is right away. But it's actually very easy to find because we know that this is symmetrical. So therefore, the axis of symmetry, which will find the vertex, is in between those 2 points. If you count the spots, 1, 2, 3, 4. Alright, we have 4 spaces in between those 2 dots. If we cut that in half, basically, this is the axis of symmetry. I'm going to call it AOS, axis of symmetry. Is located at x is equal to, let's see, that's 0, this is 1. So axis of symmetry is located at x is equal to 1. Now that's going to help us a lot because that's actually the x coordinate of my vertex. Okay, so again, that's the x-coordinate of my vertex. Now to find the y-coordinate, all we have to do is plug in that 1 back for this x and that x. So we're going to plug in, let's see, 1 minus 3, and then we have 1 plus 1. Okay, that's going to give us y is equal to 2 times negative 2 times 2. So if you do multiply those together, you get negative 8. Alright, so that's actually going to be the y-coordinate. This is going to be the y-coordinate of my vertex. Okay, so once we have that, we're going to come over here and we're going to go down 8. Right on this line. We're going to go down 8, which is located right there. Now that's really all I care about. I mean, you have 3 points. Yes, this is being stretched by a factor of 2. So if you want to actually put all the points, that's fine. But I'll be happy if you just do at least that. Right, on problem number 6. Alright, we have 2 roots, positive 2 and positive 2. Which is strange because it's the same number. So we have, this is actually called a double root because both roots are the same number. And this is actually going to be a whole lot easier because if that is the point, that double root, the axis of symmetry is located right on that point. And again, that only happens if your roots are the same. If your roots are the same, then your axis of symmetry is going to be running through that root. So the last thing we need to take care of, so again, the vertex is going to be 2, 0, is that negative 1 is going to make this reflect over the x-axis. So instead, it's not being stretched. So instead of going to the right 1, up 1, I'm going to go to the right 1 and down 1. I can go to the right 2, down 4. I'll just call it good right there. And that's how you do it. Alright, again, I do not mind if you use your calculator to check your answers, but do not do all of this with a calculator, because that's not going to help you. Alright, so let's take a look at one from the homework. Let's see. Now there's only one that is harder than the other, but okay, let's look at this one right here, number 9. Alright, on number 9, we're going to try to find our vertex. Now remember, this is the root form. I have 2 parentheses with 2 different numbers. Alright, so that implies that my roots are x is equal to 3 and x is equal to negative 1. Alright, so we're going to come over here and say, well, this is 3 and this is negative 1, which is very similar to the problem we just finished. Okay, so it's almost the same problem as a matter of fact. So the vertex is going to be located right the midpoint between those 2 points. That's going to be where my axis of symmetry is. So my axis of symmetry is going to be x is equal to 1. Alright, so we have that our vertex is going to be located at 1. Now to find my y-coordinate, I'm going to plug in 1 for x. So we have y is equal to negative 1 minus 3, 1 plus 1, which is going to give me negative of a negative 2 times 2. So that's going to be y is equal to 4. Okay? So that point is going to be located 1, 2, 3, 4. Well, it's a parabola. It's not being stretched, so let's just call it good right here. Again, I don't really care if you fill this tables out. I don't. Just make sure you know how to draw it by hand without a calculator. Alright, if you got any questions, make sure to ask the subs. You should have a key, but do not copy the key. Make sure you put in the work.